Hello there, Mr. Sutton here, bringing you the Pre-Cal Honors 2-2 lesson on synthetic division. In this one, we will be determining if a binomial is a factor of a polynomial using synthetic division. Let's begin with an easy warm-up here. Complete the sentence. 4 is a factor of 20 because, pause the video and take a sec to ponder that and write your answer. Now there's lots of possible answers. The one we were looking for here is 4 is a factor of 20 because 20 divided by 4 has a remainder of 0. You might have said, well, 4 is divisible into 20. Sure, but divisible means you can divide 4 into 20 with no remainder. So this is the key, this remainder of 0. And this brings us to our first big theorem of the day, the factor theorem, which says if you divide a polynomial, p of x, by some binomial, x minus a, this could be x minus 2 or x plus 3, whatever. If you do this division and you get a remainder of 0, then that means that binomial just divided by is a factor of p of x. Now you might say, well, how do we divide a polynomial by a binomial? We'll get there. For now, all you need to think about is if you are able to do this division and you get a remainder of 0, you've just found a factor. Now we can take this a little bit further. If x minus a is a factor of p of x, that means that there is something you can multiply x minus a by to get the original polynomial, p of x again. If x minus a is a factor, then you can say p of x equals x minus a times something. Now here's where it gets really neat. If you were to plug in a value for x that was equal to this number, if you had plug a in here for x, a minus a would be 0, and then all of this stuff would come out to 0. So that means that p of a then has to be 0. If x minus a is a factor of p of x, that means you can factor it up like this and plug in a, and you can get 0. Now this brings us to one more neat theorem. Notice that when you divided by x minus this number, and when you plugged this number in, you got the same result, remainder of 0, function value of 0. This brings us to the remainder theorem, which says that p of a and the remainder from p of x divided by x minus a, in other words, plugging in a number and dividing by x minus that number, give you the same thing. That remainder and that function result are the same thing. That'll be huge later on in the lesson here. Before we can look at synthetic division of polynomials, we need to look at long division of polynomials. And before we can even look at that, we need to look at long division in general. So let's take a look at just a arithmetic long division, just normal numbers here, constants. Pause the video and see if you can remember how to do long division on this problem. All right, so we've got 654 divided by 7. So we set up our little division box. 654 is inside, 7 is outside. 654 is the dividend, 7 is the divisor. We see how many times the divisor goes into as much of the dividend as possible. 7 doesn't go into 6, but it does go into 65. It goes in 9 times, and then we multiply that back times the divisor to get a number. So 9 times 7, that's 63. We put that underneath the 65, and then we subtract. 65 minus 63 gives us 2. So we have this divide, multiply, subtract kind of thing going on. Now we keep going. We pull down the next number, the 4 here, and now we do a divide, multiply, subtract again. We divide 7 into 24, and that goes in 3 times, which we put up here. And then we multiply 3 times 7, that's going to be 21. And then we subtract again, which gives us 3. So this 3 is the remainder, and this 93 is the quotient. So that's long division with normal numbers. Now let's do long division with polynomials. So let's say we're dividing y squared plus 5y plus 5 by y plus 2. How would that even work? And we also want to ask the question, is this divisor here a factor of this dividend? Because that'll be important too. Now over here we saw that 7 is not considered a factor of 93 because the remainder is not 0. And the same thing's going to apply over here, but let's check out the process. So we do the same thing as before. We set up a little division box with the thing you're dividing into inside. And then long division, you you just take the first term of the divisor and divide it into the dividend. So we're not dividing y plus 2 into this whole thing right away. We're just going to take y and see how many times that goes into y squared. Well, y squared divided by y would just give us another y, which we'll put up here right above the 5y, because this is the y column here. And now we multiply just like we did over here. So y times y plus 2, that's going to be y squared plus 2y. And then just like we did over here, we're going to subtract. So y squared minus y squared is going to cancel out. 5y minus 2y is 3y. And just like before, we bring down the next thing, which is this plus 5. And we divide, multiply, subtract again. Y goes how many times into 3y? Well, 3y divided by y gives us 3, so positive 3 up here. And then multiplying that 3 by the y plus 2, that's going to be 3y plus 6. And then we subtract again. So those 3y's cancel. 5 minus 6 is negative 1. So then we end up with a remainder of negative 1. And the quotient is y plus 3. So there's long division with polynomials. And to answer this question of whether our divisor is a factor, well, a remainder is not 0, so this is no, not a factor. So the trouble with long division is, well, it's long. It takes a while, and that was only just a quadratic divided by a binomial that we just did with long division. So we're going to do the same exact problem again, except this time we are going to use something called synthetic division, which basically is a process of doing the same stuff but doing it a lot faster. And we're also going to figure out if the binomial is a factor of the polynomial, and we're going to explicitly find the quotient. So our first step with synthetic division is we're going to write down the coefficients of the dividend, a line below those, and also a from x minus a. So what we're saying is by the coefficients, we mean the coefficients of this dividend right here. So we have a 1 for 1y squared, we have a 5 for 5y, and we have a 5 for the constant 5. Next, I'm going to write a in a box, a from x minus a. So basically I'm saying whatever zeroes out this binomial factor. So in this case, that would be negative 2, because negative 2 plus 2 would give me 0. So I'm going to put a negative 2 in this box over here. I'm going to write a line. I'm going to leave a little space and then write a line below my coefficients. And now the process continues. So our next step is to bring down the first coefficient and put it below the line. So this 1 is our first coefficient. That comes down here automatically. If you want, you can think about it as adding 1 to an invisible 0, and you'll see why I say that in a sec. Our next step is a few steps here. We're going to multiply this box number, negative 2, by the number on the bottom. So we have negative 2 times 1, which is going to give us negative 2. Now what do we do with that number? We're going to put that number in the middle row under the next column. So I'm going to do negative 2 right here underneath that first 5. Next, I'm going to add that second row to the number above it in the first row. So we have negative 2 plus 5. That's going to give me positive 3. All right, and then we're just going to repeat this process until we get the final number on the bottom. So let's see here. We've got negative 2 times 3 now. This next number, that gives us negative 6, which we will put up here under the next number, so under 5. 5 plus negative 6 is negative 1. Okay, so you've gotten to the end, you've run out of numbers, now what? So that last number, that's your remainder. And so we can say remainder, negative 1. Now if that number is 0, you just found a factor. Y plus 2 would be considered a factor. If the number's not 0, then y plus 2 is not a factor. Since negative 1 is not 0, we can say y plus 2 is not a factor of this polynomial. We can't split this up into y plus 2 times something. And to write the quotient, all the other numbers on that bottom row are the coefficients of your quotient, which is going to be 1 degree lower than the polynomial you started with. So this 1 in red, that was your remainder. This 1 and 3 that I color-coded in blue, those are the coefficients of your quotient. So our quotient then is going to be 1y plus 3. Now, how do I know this is 1y and not 1y squared? Well, I divided a y squared by something with a y in it. So that's going to give me something that starts with a y as the highest power. So there we are. And just really quickly, it's fun to note that what we got here, y plus 3 remainder negative 1, is what we got when we did this using long division on the last slide. Y plus 3 remainder 1. Now that you've seen the process for synthetic division, pause the video and see if you can apply it to this problem, dividing this polynomial by this binomial, seeing if the binomial is a factor, and then finding the quotient. Alright, so our first step, just like before, we write down the coefficients of the dividend. So we've got 3, and then minus 7, plus 2, and then plus 3. And our box number this time around is going to be 5, because 5 minus 5 would give us 0 for that binomial. And then we draw a little line down below. Bringing down our first coefficient, we have a 3 down here, times 5 gives us 15, plus negative 7 gives us 8, times 5 is going to give us 40. 2 plus 40 is 42. 5 times 42, that's 210. And 3 plus 210 gives us 213. So we end up with a remainder of 213. Since that's not 0, x minus 5 is not a factor of the polynomial. And our quotient is going to start with a 3. Since we started with a 3x cubed, since we had an x cubed and we divided by x, that should give us an x squared for our first term. So this 3 down here means 3x squared. And then this is going to be a plus 8x plus 42. And again, the 213 doesn't get used because that was the remainder. Here's another example for you. Pause the video and just do the setup for this one, but don't go through and actually crunch all the numbers. All right, so for our setup, we have a coefficient of 1, negative 6, and not 22. So here's something that's a little tricky on this one. Notice that we skipped from x cubed down to x to the first, so that there's an invisible 0x squared that we're not bothering to write here. So you do need to have placeholder zeros when you see missing terms, or when you don't see them, as it were. So we have to put a 0 here for the 0x squared that we didn't write. And then 22 is the next number, followed by 40. Box number on this is going to be positive 4. We have our line. We bring down the 1, and actually pause the video and finish this one off if you want. So we have a 1 down here, times 4 is 4, plus negative 6 is negative 2, times 4 is negative 8, plus 0 is negative 8, times 4 is negative 32, plus 22 is negative 10, times 4 is negative 40, plus 40 is 0. So we have a remainder of 0, and that means that x minus 4 is actually a factor of this polynomial. So our quotient on this one, we're going to have a 1x to the third power, because we started with x to the fourth, and it's always one exponent lower than you started with, because you're dividing by an x. And then our next term is negative 2x squared minus 8x minus 10. And here's one extra little thing that's worth noting in this problem as to why you would care whether the binomial is a factor or not. Since x minus 4 is a factor, we can rewrite p of x, the original polynomial, as x minus 4 times this quotient that's left over. So we could actually factor it like this. And this is a technique, if you know that something's a factor, that you could use if you wanted to break things down with situations where other techniques don't work. For this last problem, the final boss battle, we want to know if x plus 1 is a factor of 4x to the 736 and all the rest of this. Now, before you freak out, it might be worthwhile looking back at the beginning of the lesson where we went over something called the remainder theorem, which says that given x minus a, the remainder from dividing by that is going to be the same thing you get as if you do regular substitution, if you just plug a into the polynomial. So instead of dividing this thing synthetically by x plus 1, we could find the remainder by just plugging negative 1 directly into this polynomial. So let's go ahead and do that. That's 4 times negative 1 to the 736, plus 5 times negative 1 to the 97, minus 20. And we're just raising negative 1 to an even exponent here, so it automatically comes out to positive 1. So that's just 4 times 1, or 4. Negative 1 to an odd power comes out odd, and this is going to be negative 1 times 5 then, which is negative 5. We still have that minus 20 there. 4 minus 5 gives us negative 1. Negative 1 minus 20 is negative 21. And remember, this is the remainder that you would have gotten if you actually divided this polynomial by x plus 1, either long division or synthetically. So since this is a remainder that's not 0, that means x plus 1 is not a factor. Now, you might be wondering, why did we bother doing any of the stuff for the rest of this lesson if we could have just plugged in the a value the whole time? Well, yeah, this tells you whether or not you've got a factor or not. It does not give you the quotient, though. So if you needed the quotient for anything, synthetic division is about as good as it's going to get. So that's it for this one. Till next time, this is Mr. Sutton signing off.